and welcome to another episode of FooBar. Today we are going to talk about how to prevent injection in your application and how to cover and mitigate other of the OWASP risks. We will focus on using AWS Waf and how it can help you out in your serverless applications. If you don't know what is OWASP, is a list of the top 10 vulnerabilities for web applications. They also have done a list of the top 10 vulnerabilities for serverless applications. I'll leave you the link below so you can check them out. Some of the things in this list are shared, some of them are exclusive for web applications and or for serverless. Injection is on the top of both lists. It's a very critical thing for web applications and also serverless applications. So, what injection means, you might be wondering. Well, that means that you get a trusted input from some of your surfaces, like attack surfaces that you will call, and that untrusted input is kind of an attack vector, and that will be processed in your code and will do things that you didn't expect to. So for example, imagine you have a database. I think these are one of the most common examples. So you have a database and you have an application that is running a query into that database. So if you don't have a kind of way to prevent this injection, somebody might be able from an HTTP request, for example, to drop your table in that database. There are many ways to prevent this, so don't panic. But in general, it's like how malicious attackers or malicious users can do things in your systems that you were not aware and you didn't want them to do. They can not only delete your database, but drop tables. They can access secret information. They might be able to extract things that you didn't want them to extract, like all your customers list. There is many types of injections as well, not only in databases. I think databases are always a great example because they are very, very visual. In the web world, in general, when we think about injection, we think it from the perspective of REST APIs and how we can secure that. In serverless applications, injections can happen in multiple places because functions are triggered from different types of event sources, and those can be a vector from an attack. So the amount of places where these attacks can happen is bigger, but again, you might have access and control to who creates those events. They might be internal to your application, so there is nothing to worry. But it's important to have that in mind. There's many ways to prevent injections in the serverless world, so again, don't panic. Your attack surface is bigger, but if you are tidy in how you process your inputs, no matter if they're coming from HTTP requests or from, I don't know, messages, queues, or buses, or any outside service or third-party services, then that should be enough. Also, in general, never pass data that came from outside into another API. Always try to sanitize it or do some kind of interpretation on it, like making sure that what you're passing through is what you really want to pass through. It's very important also to use this kind of parameterized input. So for example, you create, if you are running an SQL query, for example, you can use an service like is creating these inputs for you, or you can even, if you are using Node, do a string where you have a specific parameter and nothing else than that parameter can be input. So different ways of sanitations are important in your input data. Also, functions are great because if you limit the amount of permissions they have, they might not be able to do any damage. So for example, if somebody is able to inject some data that gets all the elements from your DynamoDB table, but that particular function only has access to write on the table but not access to read all the elements in the table, then doesn't matter what happened, that function will not be able to execute that command that is given from the outside. So having a very limited set of permissions is important. And then if you are worried about your HTTP request and your external APIs, then you can use a firewall. A web application firewall that works in the layer 7, that is the top layer of your network network layers of your application will help you to prevent all these injections and help you to keep your application very secure. Also, some ways to prevent injections if you are using AWS are, for example, to use AppSync. AppSync is a GraphQL server, one of kind of managed server that will, when you're using GraphQL, then your inputs are very sanitized because the GraphQL schema requires you that you pass an exact object of the exact type, and you cannot get out of those defined schema. So that's a great way to validate your inputs in a very automatic way. Also, API Gateway has a very basic validation of the request, so you can use that. And then you can, as I said, use an application firewall, and for that we have AWS Waf. So this episode will be mostly about AWS Waf because the rest of the things are things that you can do programmatically or quite simply by just using some service. So Waf is a service I never covered. I have a series on security mechanisms with API Gateway, and I think this video should belong to that series, even though AWS Waf is not part of the AWS of API Gateway offering, but it kind of prevents API Gateway from receiving malicious attacks. But yeah, so this is kind of in that line. So we are going to talk about AWS Waf. If you like the video until now and you want to know more about AWS security, just leave it a like and subscribe if you're not yet subscribed. So AWS Waf is a web application firewall, and that helps you to protect your APIs against common exploits. So basically, Waf will give you a way to control the traffic that goes through your application. It's a kind of taking all the requests and analyzing them according to some rules. It prevents things that are like very basic attack patterns like SQL injection, cross-site scripting. It has a list of malicious APIs that Amazon is collecting, AWS is collecting, and if you can block those malicious APIs. So there is many ways, and they have a set of rules, for example, that are kind of aligned with the OWASP risk. And there is also a possibility to get rules from organizations from the marketplace that are selling these rules. So if you want something very specific, like a set of rules that protect your serverless application against OWASP risk, there is a particular company that sells those. So you can get them. There are different types of rules when you use AWS Waf. They have the managed rules, that are these rules that are from AWS or third-party providers, and also you can define your own rules. And when you define your own rules, you can block certain IPs or only allow certain IPs, or allow from some country in particular, or deny from some country, and then mix and match all these different things. So it's quite powerful. And Waf works with CloudFormation, it works with load balancers, it works with API Gateway, and also with AppSync. So it kind of sits there and help you a lot. You can test this Waf, and you will see it in your metrics as well. You have a CloudWatch metric that it will tell you when these rules are kind of triggered. And you can see it in a really nice graph when things are going wrong. So let's go now to the console and explore a little bit AWS Waf and see what we can do. From the AWS console, I just type Waf and I can open it. And there I can create a new access control list and ACL. And there I put a name to my new control list. And then I need to put a CloudWatch metric. You can pick in which region you want to do it. And I will use a regional resource, or you can do it for your CloudFront distribution. Then you can attach different AWS resources. Here you can attach load balancers, AppSync, or API gateways. I will not do anything yet because we will do that in a second through CDK. Then you can add rules. So there is many rules. There is the managed rules, or the rules that you create. And the managed rules, the list is here. You have the AWS managed rules, and there you can decide if you want to add it or not. And you can see that there is this different explanation for each of these rules and what they do. So that's pretty neat. I like the core rule set that protects against basic OWASP. And if you are preventing, if you have an SQL database, for example, the SQL injection is quite cool. If you have a WordPress site, the having the WordPress is quite cool, and things like that. So I really like this. This list is quite comprehensive for all kind of web applications out there. If those rules are not enough, then you can go down and you can see the rules that our partners are providing through the AWS Marketplace, and you can go and purchase it from the marketplace. So that's kind of nice. It's very simple, and you get very detailed different types of rules. And in the marketplace page, you can find more information on the rules. And then you can continue and add those rules, and then we can also define our own custom rules. There is 3 types: IP set that are allowed or denied, then some kind of different parts of the request, like the country we originate from, or if it has something on the particularly in the request, some body, some header, or whatever, that will be blocked or allowed, or it will be just counted. So this is pretty neat. You can mix these rule groups that you have created, or you can use IP sets that you have, for example, in your company. You're only allowing people coming from this set of APIs, or you are not allowing at all. Then you can move up and down the rules. The rules are ordered in a priority, so if the rules are evaluated in that order, so if something is allowed in the first rule but is denied in the second one, it will pass the first one, it will get denied in the second one. If it's denied in the 2 places, it will get rejected for the first rule. So that will affect your metrics and your logs, so you will see who rejected or who accepted what. And then when you are configuring, you can put a name for your CloudWatch metrics and decide on your sampling request. And this is kind of nice because then you can view the request that match your ACL rules. So I will have it enabled so I can see them. And then I click next, and basically now we can have our ACL. But I will just remove it because we are going to build this from code, as I always like to do it, infrastructure as code all the way. So we are going to build it using CDK. So for starting this project, I will not start from scratch. I will start from a video that I did in the past. That is the Aurora Serverless database, where I set up an Aurora database with a Lambda function, an API gateway, and basically I will try to add a WAF in front of that prevents SQL injections in that database. So we are adding one more layer of security to that database to prevent any kind of malicious attacks in our SQL database. So for that, I'm going to clone and get the code from the Aurora Serverless GitHub repo. If you want to follow the steps on what you need to do in order to get this working, I leave you the link in the description so you can follow the steps. It's pretty straightforward. Basically, after you clone this repo, you will need to push this, do CDK, deploy, then go to the Aurora, create a table, and then you're ready to start this video from where I'm going to start. So that's in a nutshell, but if you want to see how we build that Aurora database, the video is in the description box. So to that project, we need to do a couple of changes for it to work. The first one, this project that we got from Git is using API Gateway version 2. And WAF is yet not supported in API Gateway version 2, so we need to replace API Gateway version 2 with the older one. So we are going to do that first, and we are going to our lib and to stack, and there I'm going to basically replace that with the version 1. So that's the first thing we need to do. And also we need then to install that dependency because it was not added in originally. So now we have ready everything to use the API Gateway version 1. We can replace that. And there is not much code we need to change, but we need to do a little bit of change in the way that we are creating that API Gateway. So I will replace that little piece of code from line 39 to line 44 with a little way to create the API Gateway. It's the same method hello that we had before with the same any integration, so nothing weird here. So the same thing from the outside. And you can see that the post function is in red, and that's just because CDK. I have this project running. I created this Aurora project some weeks ago, and they updated the CDK version. So this is something that will happen to you as well. So you need to go to the package JSON and update the version of all the CDK components to be the latest one. In my case, it's 89, but if you're watching this in the future, it might be 1992, 93, who knows, because they keep updating CDK a lot. And now that I'm here, I can also remove the API Gateway version 2 and the integrations because I'm not using them, so I can remove them from the dependencies, and that's kind of great. Less things in my node project. And now when I'm ready with that, we can run remove the node folder and then run npm install. So after running npm install, my dependencies are updated to the latest version of CDK, and we will not see that error in the post function. So good, now my API gateway is updated. We need to do one more update for API gateway, that is to change the code of the Lambda function to get the right parameters in the index.js. So we are going to do that. I will open my index.js and I will just change the switch from the event request contact HTTP method to the right parameter, that is HTTP method for API Gateway version 1 differs from version 2 in what it brings in the event object that it sends to the function. The rest can stay the same, but the HTTP method is in a different place on version 1 and version 2, so don't forget to update that. So now we have API Gateway version 1, we can attach it to a WAF. But before that, I want to make my application a little bit more insecure, so it's easier to inject something on it. I'm not a hacker, so I will do it a little trick here. So I will go to my get to do. We are going to try to hack this part of the application. Again, I'm not a hacker. So I will make this query a little bit more dumber. So we talk about sanitizing the inputs and doing parameter size queries. And this is what I'm doing here. I'm building this select from with a parameter, and then I'm calling this query with that parameter. So this is very hard to hack because, well, it just doesn't work if we try to pass things. I'm sure somebody can hack it out there, but I'm not a hacker. So I will dump this down. I will make it less good so we can break it. So basically, I'm creating another query line, and that is a stupid string. So before we have a parameterized string, and now we have a basic string that we are forming with pluses. And then I'm going to pass that query without the parameterization into the database API. So this will make my whole application a little bit more weak. So now when this finishes deploying, you will see an API. Just grab it and then paste it in Postman. And if you run it, because this application, I had it running from the previous video, I have something in my database. You might have it empty, so you might need to populate that table with something so you can hack it. But yeah, so I have something in my table. I have 3 items. If I do a get with no parameters, basically I get all the items in the table. Then I can grab an ID and try to get that particular ID. And I can do that. I can do a query string parameter with that ID. And then I should get that element back. Pretty straightforward. But now I can run a little hack. I can run an SQL injection. I have not done SQL injections in my time in high school, in university. So this is a very dumb one. But I'm just writing a random ID. You will see that it's 105. I don't know the IDs in this database. And then you see that I'm putting a little comma because I imagine that this application is having an ID of the type string, and then I need to close that string. And then I type in OR and A equal A, and I'm not closing the second A. So in this way, I have a little kind of injection here because the ID will not match anything in my database. That will be a false, but the OR will be true because A is equal A. So this will return everything on the table. In the case of our application, because I'm only returning one item, the first one in the list, the attacker cannot see the whole table. But if I will not be doing that sanitization of the outputs, then the attacker will get access to all my data. But because I didn't dump down that part of my application, then you cannot see them all. But if I send this is not failing. This is a clear SQL injection. It's from first grade. And I'm getting the first element in my table. This is not what I want. We don't want to get any results. We don't want to leak any information. If you don't have the right ID, you should not see anything. And in here, there could be things like drop the table or remove elements on the table. So this is very, very dangerous that is able to be done. So we don't want to do that. We want to do something to prevent this. So what we are going to do is to add a WAF in front of this API gateway to prevent SQL injections and other malicious attacks. So for that, we are going to create another CDK stack. I like to create multiple stacks if possible. It's cleaner and they appear independently in CloudFormation. So I will go to my lib and I will create a new stack. You can do it in the same one. I like to do it as separate stacks. Just put a name. I started with WAF TS and then I realized that's not very descriptive, so I put something very descriptive, CDK WAF stack. You know, I'm very good at naming things. And then I will throw a lot of things in here and then we can go line by line to see what exactly everything means. So the first thing we see there is that we have the import as read. We have not imported that component, so the first thing we need to do is node install that component so we have WAF available for us. So we do npm install blah blah blah. After it installed, then we can use the WAF component in our application. And what we are going to create here is a WAF with a couple of rules, and that is linked to the API gateway that we created. So we will have this kind of, we need to get the ARN, Amazon resource name of the API gateway we created previously in order to attach it here. So that's why I have this little interface here that we will be exposing it, and we will be sending this parameter when we define the application, the stacks later. And then you will see inside the constructor, we will have two rules. The first one is the manage common rule set from AWS. And the rules are all more or less defined a similar way. You will have a name, you will have some kind of role group statement where you can exclude some internal rules of the rules. You can define if you want to have the CloudWatch metrics enabled. If so, you need to put a metric name. If you want to have the sample request enabled. All these things we saw when we were creating in the console the options, and now they are all visible here. So this is quite clear and very straightforward. And then we need to put the priority. This is the order on which the rules are going to get evaluated. And then we push it to this array of rules. And then I added another rule that is the SQL rule manage from AWS. It's in the level 2, the priority 2. And then again, I have some kind of visibility and configuration on the CloudWatch metrics. Again, I push it to the array of rules. And then we will create our ACL. And there I just put what kind of ACL I want. I want a regional one that means onto a resource like load balancers, API gateway, or AppSync. And then I want it to have the CloudWatch metrics enabled and give them a name again. And then I attach the rules. And finally, what I will be doing is associate our API gateway with this WAF. So that's something we need the API gateway ARN to do. For doing that, then I will go to the creation of my application, that is the CDK Aurora Serverless TS, where we are creating all the stacks. And I will import this new stack that we just created, the CDK WAF stack. And then I'm going to basically create an object of the serverless Aurora stack that we had defined. So that object, the API gateway stack, I will call it, will have the resources like the API gateway, the Lambda, the Aurora serverless, and we can then inspect it and get the ARN. Then I'm going to build another object for the WAF. we need to pass that property that is the API Gateway RNN that we got from the API Gateway stack. So you can see that this is in red because we have not created yet this attribute in the stack, so we will do that in a second. But first I want to make sure that the WAF stack has a dependency on the API Gateway stack. That means that the API Gateway stack needs to be created before the WAF stack, so that's how CDK will know. So the last thing is to make that API Gateway RNN visible in the CDK Aurora Serverless stack. And for that, I'm going to add this, basically, we'll create a new property in this stack called API Gateway RNN, where we are going to put the RNN of this API Gateway. And this will be visible from outside of the stack. And with that, that's all. Now we can deploy and we can test. When you have multiple stacks in your CDK application, you need to deploy with --all, and that will deploy all the stacks in the right order with the right dependencies. So when that's finished, I will come back and we will see how we can test this. So now it's completed and we can go again to Postman and run those malicious queries to see how our application responds. We get a forbidden, so that's great. Now our injection doesn't happen anymore, the firewall is catching it. We can try other things. For example, we can add a body, and this was, if you check, I didn't show it to you, but if you test it before, and also I show it in my Aurora video, if we pass a body and we are just doing a get, basically the whole thing goes through because API Gateway doesn't care. But with this WAF in place, that's also an error because we have this kind of security in place that doesn't allow to pass extra things, and get should not have bodies. So if we go back to our AWS console and we check the firewall, I will open the right one and we can see what we can see, what is available for us. So we go here and the first thing we'll see is a kind of a graph showing us the request in the last period of time. This request goes every 5 minutes. That's the kind of granularity, and we need to wait a little bit for CloudWatch metrics to refresh, but after a little moment you will start seeing the table. After a while you will start seeing some changes in the table with the forbidden request that we sent. We can see in this table now that we have 2 requests that were blocked, and they were also for the SQL rules, so that's pretty neat. If there will be other kind of blocking or other kind of allow requests, we will see also those little dots. So we could have the counted can be 10, 5 can be allowed, 5 can be blocked, 2 can be blocked with SQL rules, others can be blocked with the common rules, and so on and so forth. So that's pretty neat, and you can get an information on your CloudWatch metrics. So thank you for watching this video. The code is available in GitHub in a repo. I will leave it there for you so you can play with it. And if you want to see more content about security, let me know with a like or with a comment exactly what you would like to watch. This is a video you were expecting forever, and now I come to do it. Eventually, I try to make the videos that you want to watch, but sometimes it takes me a while. So thank you very much. Have a great day, and I see you in the next episode of FooBar. Ciao, ciao!